In this video, we're going to talk about exponential decay. I have a story problem here that we're going to walk through, and I will show you the important steps when doing these. So we got a radioactive isotope. It decays from 50 grams to 18 grams in 1,000 years. And the question asks, what is the half-life of the isotope in years? And of course, I want you to get the rounding just perfect to 3 decimal places at the end and without rounding throughout your analysis. So let's just write out what we have. Let's see, we've got this thing decreases from 50 to 18 in 1,000 years. So it goes from 50 and it goes all the way down to 18, and 50 is where we start, right? So this is like time 0, and then 18 is at 1,000 years. Okay? Just kind of writing out what we have. And the question wants to know, what is the half-life in years? So we're looking for years, right? And we want to know the half-life. That is what we're trying to find. Really important, right? So we're going to be looking for a t, for a time, right? You can't forget to 3 decimal places. Okay, so step 1 is going to be find your equation, right? And I'm going to rewrite these. The way I like to see it is as a set of points. So you're going to have like x comma y. In this case, it's t. I always use t for time because that makes more sense to me. So it's like time and output, how much we have left of our isotope. So at time 0, I'm at 50. And after 1,000 years, time 1,000, I'm at 18. Okay, cool. So I have these points. Equations, exponential equations always come in the form so perfect. I just need to find the equation in this form, and that means that I only need to find A and B. So I'm just going to say, when finding the equation, find A and then find B. So boom, A jumps right out at me. How do I know what A is? A is my starting point. So at time 0, I'm starting with 50 grams of this isotope. So boom, I've already got that. Plug it in. Perfect, I've got A. Now I just need to find B. How do I find B? Well, I'm going to use the information from this other point to plug everything in for T and for Y, and then I'm going to solve for B. Okay? And solve for B. Okay, so Y is 18. And T is 1,000. Perfect. So now I just need to solve for B. All right, here we go. I'm going to isolate B and, well, I have to isolate it with this power first. So I'm going to get rid of this 50. 50 is being multiplied. I'm just going to undo multiplication with division. Yes, it really is that simple. Okay, and then 18 out of 50, this can be reduced. And I don't think I can reduce that any further. Okay, now I just have to get rid of this power, right? How do I undo a power? I undo it with a square root, and whatever the power is, that's the root I'm going to take. So this is the 1,000th root of 9/25, or the 1,000th root of b to 1,000. Who knows what this is? I don't know. I don't care. They undo each other, and I just get back b. This is just a calculator question. So how do I type this into the calculator? I'm going to do 9/25 to the power of 1/1000th. Because remember, the root is just a fractional power. So let's go over to Desmos, and I'm going to make sure I type this in correctly. And here we are. I am just using my keyboard here, not even, and notice I got to bring this cursor back up in order to close my parentheses. Otherwise, it'll just put an extra set of parentheses around the 25. And then to do 1/1000th, it's another fraction, right? So I need to do more parentheses to show that this is a serious fraction. Or you could do it as a decimal. That would totally be fine. Oh, and I forgot to say there to the power. Here we go. To the power. Oh, you've got to be kidding me. Okay. Copy paste. Here we go. Okay, so I get 0.99897888705, right? Now the calculator knows this whole number because I have it all right here. This is one number, right? I don't know if this calculator online, I'm not super familiar with Desmos. I don't know if they just like rounded this 5 or if it actually ends there. I think they round it. I'm going to hit enter. And then on my paper, I'm just going to put 0.9, right? That's not even the correct rounding. But I'm just going to put 0.9 just as like a little placeholder. And then when I find my actual answer, I'm going to use this whole number. So that way I'm not rounding it now and propagating error throughout my analysis. Okay. So I'm just going to write 0.9, but we all know that that's not even correctly rounded, because if I rounded it up to 1, that wouldn't change anything. I'm looking at a decay factor. So for now, I'm just writing 0.99, but we're going to use that whole number in our final answer. Okay, so now B, I'm just going to say equals 0.9. Cool. I found B. So now that means that my equation, I have A is 50 and B is 0.9. 0.999. So my equation becomes 50 times 0.9 to the power of t. Great. Now we notice that this is less than 1, right? So whatever the decay is, we'll just say that that is 1%, right? Got us to 0.99. Remember, B, if it is growth, it's 1 plus your rate of growth. And if it's decay, it's like 1 minus your rate of growth. So it looks like I'm decaying by 1%. This is 100, 1, standing for 100, minus my 1% leaves me with 99%, right? Or really, really close. It's actually less than 1. It's decaying by less than 1% every year. But I know this is decay because it's less than 1. If you get a number for B that's greater than 1, it's increasing. You're multiplying something by a number greater than 1, it's going to be increasing every year. All right, so I'm pretty sure this equation looks good. And now I need to find, I found my equation. Step 2 is going to be to find my half-life in years. Okay. All right, and now for the half-life, right, we're just going to take wherever it starts, and then we're going to do half of that. So I'm just going to say, okay, my half-life, my output is going to be half of whatever my starting value was. And now all I have to do is solve for t, right? Okay, so first I'm going to clean this up a little bit. Half of 50. And now to get t by itself, well, we're going to start kind of like the same thing we did over here, right? We got to isolate that power thing. So I'm going to divide by 50. 25 out of 50. All right, and now I'm somewhere where I have this thing, it's just tangled up in the power of this 0.9. So how do I get that out of its power? Well, I'm going to use logs. That is really the key right here, right? It's the only way that we can solve for these powers because a logarithm is a power, right? It's the only way for us to do it. So what I'm going to do is I'm going to take the log of both sides, which you know I like to use natural log. And then I'm going to use my power rule from my log rules. And my power rule states that if I take the log of anything to a power, this power comes out in front as a multiplier. So I'm just going to rewrite it in front using my power rule. And now the natural log of 0.9 is just some number. I have no idea what number it is, but it's just some number. So to undo t multiplied by a number, I'm just going to divide by that number. And now t is going to equal whatever the natural log of 1/2 divided by the natural log of 0.9 is. I have no idea what that is. It's just a number. Now, here, right here, you do not want to type in just 0.9 into this problem because that's a huge rounding error, correct? You remember, like, I didn't even round correctly. I just have this number stored in Desmos, and I'm going to use all of it. And I'm also going to use all of natural log of 1/2. I'm not going to find what the log of 1/2 is first, and then round that, and then put it in the numerator of this fraction, because that would just propagate a bunch of error in my analyses here, right? Like I rounded this and then I rounded that 0.9 and then I took the natural log of it and then I rounded that number and then I divided both of them. That's not going to be that's not going to be close enough to t. We want to get the real answer, and then we just want to round that in our answer because we need to find it to 3 decimal places. So I'm going to go back to Desmos, but you'll see I'm going to type all of this in. All right, so here we go. ln of 1/2. Notice it already started the parentheses for me for the ln, so that's nice. And then divided by the ln, natural log of, and we wrote down 0.9, but it's really all this stuff, right? And the calculator remembered that. So I'm just going to click the answer button and it'll put in for me the last answer that I got. And notice it's keeping all that stuff, right? And I'm just going to close parentheses. I think I can just click OK anyway, or click enter anyway. And there we go. So my answer is 678 point, let's see, I got to round to 3 decimal places. So 678.458 years. And I just put the little rounding thing there. And I'm just going to go back to my story problem really quick just to make sure that I didn't miss anything, right? So it wants me to find half-life. That is what I did, half-life in years, which is what I was going for, to exactly 3 decimal places. And that's what I did, right? And notice this number that I typed into Desmos here, I didn't type in the 0.9, it is the exact answer that I typed in, the exact number. And that's how I got my exact number. And then I could just round that. So I am really, really sure about that answer.